Out of a storm over Kazakhstan, a space shuttle appears. It is white, it is silent, and there is no one on board. November 15th, 1988. A secret missile range in the Kazakh steppe, low cloud, rain, a storm warning in force. 80 tons of spacecraft falling out of the weather at 500 kilometers an hour, flown by nothing but its own computers. And then, 11 kilometers above the steppe, it does something nobody ordered. It banks hard, away from the landing course. In the control room, officers freeze. The trajectory is wrong. The machine is off the predicted path. Some begin to whisper about the self-destruct command. And in a corner of the room, someone is already drafting the press statement announcing failure. They were wrong. The machine had not failed. The machine had made a decision. It was the most advanced machine the Soviet Union ever built. It flew once, and it never flew again. Not because it failed. The machine was never the problem. By the time it flew, everything around it already was. This is the story of Buran, the Soviet space shuttle. Why was nobody on board? Why did a perfect flight lead to nothing? And what finally happened to this machine? Because the ending is crueler than anything the Cold War ever did to it. It begins with the man who buried the Soviet moon rocket. Chapter 1. The Gravedigger. In May of 1974, Valentin Glushko walked into the headquarters of the Soviet space program as its new master. His first act was an execution. The N-1, the giant moon rocket of his dead rival Korolev, was cancelled on his order. The two flight-ready rockets were cut apart for scrap. The program was erased so completely that for 20 years officially it had never existed. Valentin Glushko, the brilliant engine designer, the rival from Korolev's Gulag years, the gravedigger of the Soviet moon. But Glushko did not take the job to bury rockets. He took it to build his own. His dream was a family of giant launchers, and on top of them, a permanent Soviet base on the moon. A redemption written in steel. The Kremlin had other plans. In April of 1981, the American space shuttle would fly for the first time. But years before that, its specifications were already public, and in Moscow, they did not add up. Soviet analysts ran the shuttle's economics again and again, and the numbers kept failing. 60 launches a year, cargo bays that size, wings that could swing well over 1,000 kilometers sideways on re-entry. Nobody needed that to deliver satellites. So Soviet military planners reached the only conclusion their world allowed. If it made no commercial sense, it had to be a weapon. Mathematicians at the Keldysh Institute would later model the nightmare in detail. An American shuttle swooping down from orbit in a sudden dive, dropping a nuclear weapon on Moscow, and escaping to its base in California before anyone could react. The Americans had no such plan. The physics barely worked. One of the Soviet Union's own chief designers privately called the scenario nonsense. It did not matter. In February 1976, weeks before the most famous of those studies was even signed, the Kremlin issued a secret decree. The Soviet Union would build a shuttle of its own. The fear had a champion at the very top. Dmitry Ustinov, the Minister of Defense, the most powerful industrial manager in the Soviet Union, wanted an answer to the American shuttle, whatever it cost. And in the Soviet system, when the Ministry of Defense wanted something, the space program did not get to say no. Glushko was ordered to set aside his moon and build it. By one account, he called the day the decision came down his Bloody Sunday. The system had killed Korolev's dream with his hands, and now it was killing his. In this system, it did not matter who you were. You built what the fear demanded. But Glushko found a way to win inside the order. The American shuttle carried its main engines on the orbiter itself. Glushko's engineers proposed something different: move the engines onto the rocket. That way, the rocket could fly alone, without the shuttle, as a universal heavy launcher. They called it Energia, 100 tons to orbit, the most powerful machine the Soviet Union ever built. Glushko's answer to the N1 he had buried, and they built its launch pad on Site 110 at Baikonur. The N1's own pad, rebuilt over the scars of the explosion. The new program rose quite literally on the grave of the old one. To build the shuttle itself, the state would now turn to a man it had already betrayed once, and order him to copy the enemy. Chapter 2. The copy that wasn't. The man who got the call had been waiting 20 years for it. Gleb Lozino-Lozinskiy was 66 years old, a fighter jet engineer from the MiG Bureau, the man behind the airframes of some of the fastest interceptors on Earth, and the Soviet Union's great believer in spaceplanes. Back in 1965, he had led a project called Spiral, a small winged spacecraft launched from the back of a hypersonic carrier aircraft. It was decades ahead of its time. The system starved it, stalled it, and finally killed it. He had spent the years since watching the idea he pioneered being reborn in America. Now, at an age when most men retire, he was handed a brand new design bureau, thousands of engineers, and the biggest spaceplane project in history. It was everything he had ever wanted. It just came with one condition that must have stung: build the American shape. Here is the part everyone gets wrong. Yes, the KGB stole the shuttle. Soviet intelligence harvested thousands of American documents, wind tunnel data, design papers, materials research. But almost none of it was secret. It was NASA's own openly published research, collected from public databases, conferences, university libraries. The CIA later concluded that NASA's open paperwork had been one of the KGB's best aerospace sources. America simply gave it away. So Buran's silhouette is American, and that was a deliberate engineering decision. Soviet wind tunnels confirmed the American shape was close to optimal for the same requirements. Copying it saved years. Lozino-Lozinskiy's team wanted their own design. They were overruled. But under the skin, it was a different machine. No main engines on the orbiter. All the power lived on Energia. Ejection seats for the pilots, something American astronauts after the early test flights never had. Thermal tiles developed from scratch in Soviet labs, 38,000 of them. And one thing the Americans never attempted: the entire flight, launch, orbit, re-entry, landing, could be flown by the machine itself. No human hands at all. They tested it piece by piece in one of the most thorough flight test programs the Soviet Union ever ran. First, the tiles. Small winged craft, scale models in the shape of the old Spiral, were fired into orbit and brought screaming back through the atmosphere to prove the thermal protection in real re-entry fire. They splashed down in the Indian Ocean, where Soviet recovery ships fished them out under cover of distance and silence. Until, in 1983, Australian patrol aircraft appeared overhead and photographed one of the secret spaceplanes bobbing in the waves. The pictures landed on Western desks within days. The West now knew the Soviets were building a shuttle. Then, the landing. At an airfield near Moscow, engineers built a full-size Buran with 4 jet engines bolted to its tail, something NASA's test shuttle never had. The American enterprise had to be carried up on a Boeing and dropped. The Soviet test shuttle simply took off from the runway by itself, climbed, cut its engines, and practiced falling. 25 test flights through the late 80s, and again the pilots lifted their hands from the controls and let the computers land it. By the late 1980s, the machine was ready. The question was whether the country still was. Chapter 3. The Empire's Last Project. Buran and Energia became the most expensive project in the history of the Soviet space program, on the order of 1 million people, and somewhere between 16 and 20 billion Soviet rubles. More than the N1, more than anything before it. The scale bent everything around it. Energia's fuel tanks were too wide for any train, any road, any canal in the country. So engineers took a 1950s strategic bomber, reinforced its spine, and strapped rocket sections to the top of the fuselage, a flying machine carrying cargo wider than its own body. It made over 150 of those flights, wobbling across the steppe with the future on its back. And when even that wasn't enough, they built the largest aircraft in human history. The Antonov An-225, Mriya. 6 engines, 32 wheels, a wingspan of 88 meters, designed for one purpose: to carry Buran on its back. In Ukrainian, Mriya means the dream. Remember that aircraft. Its fate belongs to this story too. The rocket itself was a monster worthy of the empire. 4 boosters, each powered by a single engine with 4 combustion chambers, the RD-170. To this day, the most powerful liquid rocket engine ever flown. A hydrogen-burning core taller than a 15-story building. 100 tons to orbit, the class of rocket the N-1 had died trying to become. In May 1987, Energia stood on the pad for the first time. Strapped to its side, instead of a shuttle, was a long black cylinder called Polios. Officially a test payload. In reality, a prototype for an orbital weapons platform built around a megawatt-class laser program. The laser itself was not on board, it wasn't ready. And according to the weapon's own chief designer, it was Mikhail Gorbachev, visiting Baikonur days before launch, who personally forbade testing even what was. The General Secretary was negotiating arms control with America. The last thing he needed was a laser battle station overhead. Energia flew perfectly. Every engine, every second. Then Polios separated, began the flip maneuver that was supposed to point it into orbit, and kept turning. A guidance error spun it a full circle. It fired its engine in the wrong direction and dropped 80 tons of secret hardware into the Pacific Ocean. The wreck was not a total waste. Its engineering lineage lives on in modules flying today as part of the International Space Station. But the pattern was set. The Soviet Union could still build machines that worked. It could no longer build plans that did. 1 year later, the machine would get its chance. But the men who were meant to fly it would not. Chapter 4. 206 minutes. A small corps of test pilots had spent a decade preparing for Buran. They called them the Wolf Pack, after their leader, Igor Volk, whose very name means wolf. Volk, the commander-in-waiting, had even been flown to space on a Soyuz just to know the feeling of orbit in his hands. They flew the jet-powered Buran off the runway again and again, rehearsing the landing they dreamed of one day flying home from space. In August 1988, 3 months before the flight, Anatoly Levchenko, the backup commander, died of a brain tumor. 12 days later, test pilot Alexander Shkukin was killed in a crash. The Corps buried 2 of its own in a single month. And when Buran finally flew, none of them was on board. Not because they weren't ready. The seats weren't, the life support systems and crew displays were simply not finished, and Soviet engineering had one iron rule: prove the machine before you risk the man. So 10 years of training came down to this. The Wolf Pack would watch their own spaceship fly from the ground. The first attempt on October 29th died 51 seconds before launch. A faulty platform failed to swing clear, and the computers stopped the countdown themselves. 2 weeks of work, and they tried again. November 15th, 1988. 6 in the morning, Moscow time. Rain, low cloud. A storm warning officially in force across the Cosmodrome, conditions in which no sane launch director volunteers to fly. They flew anyway. The program could not afford another winter. In the darkness before dawn, Energia lights. 3,500 tons of thrust shake the steppe, and the most powerful rocket in the world climbs into the storm, carrying a shuttle with empty seats. From the bunkers, the engineers watch their life's work disappear into the cloud in under a minute. After that, there is nothing to do but trust the machine. 2 orbits, 206 minutes, 83,000 kilometers flown with no heartbeat aboard. Over the dark side of the planet, over the oceans, the machine runs through its program alone, fires its engines, turns its nose home, and begins falling back into the atmosphere at 25 times the speed of sound. For long minutes, it is a meteor. Plasma seals it off from the world, its tiles glow. Nobody on the ground can do anything but wait. If the tiles fail, there is no crew to mourn, only a program. Somewhere in that fire, all but a handful of its 38,000 Soviet-made tiles hold. 11 kilometers up, in wind gusting to 20 meters a second, Buran abandons the approach its creators predicted and banks hard onto the opposite side of the runway. In the control room, alarm. By the chief designer's own recollection, there were voices suggesting the self-destruct command, and a draft statement announcing failure was already taking shape. The machine ignored them all. It had measured the real wind, stronger than forecast, and computed a new approach to bleed off the extra energy. A maneuver its designers had given a 3% probability. The correct one. Out of the cloud it came, white, silent, empty. A MiG chase plane dropped in beside it, flown by one of Buran's own test pilots, filming the spaceship that no longer needed him. Landing gear down, by its own decision. Flare, by its own decision. And it touched the runway meters from the center line, 1 second off the pre-flight calculation. In a crosswind nearly double what NASA would ever permit its shuttle, a Soviet computer had just flown a spaceplane from orbit to a perfect landing. To this day, Buran remains the only spaceplane of its era to fly an entire mission, launch to wheel stop, without a single human input. In the control room, engineers who had given this machine 12 years of their lives were crying. The verdict that went around the room: the system was not mistaken. The Soviet Union had just done something genuinely first in the world, and almost nobody saw it. No live broadcast, no crowds, a grey announcement on the evening news in a country already consumed by shortages, queues, and the slow unraveling of everything. 8 weeks later, Valentin Glushko was dead. The gravedigger of the N1, the builder of Energia, died in January 1989, knowing his machine had flown, and never learning that it would never fly again. Chapter 5. The state died first. The flight plan on paper was confident. A second orbiter, all but finished, waiting in the assembly hall, would fly unmanned in 1991. A third flight would dock automatically with the Mir space station. Cosmonauts would finally ride Buran around 1994. None of it ever happened. The Wolfpack never flew. There was never anything left for them to fly. Because there was one problem no engineer could fix. Buran had nothing to do. Every mission anyone proposed for it could be flown by an ordinary rocket at a fraction of the price. By Soviet estimates, one Energia Buran launch cost as much as roughly 50 Proton flights. And the reusable system threw away its entire rocket every time. The booster recovery it was designed for never flew. The Americans at least pretended their shuttle was an economical space truck. The Soviets had copied the answer without ever having had the question. And while the machine was being perfected, the country was failing. By 1990, the program's funding had collapsed to almost nothing. Buran was quietly dropped from the 5-year plan. In December 1991, the Soviet Union itself ceased to exist. And Baikonur, the cosmodrome, the launch pads, the shuttles in their hangars, woke up one morning in a foreign country called Kazakhstan. In June 1993, the program was formally cancelled. The most advanced machine the Soviet Union ever built had outlived the Soviet Union by exactly the length of its own funeral paperwork. What followed was quiet humiliation. The program that had consumed 1 million people's work was now worth less than the metal it stood on. A test shuttle spent 2 decades in Gorky Park, a tourist attraction with a snack stand. Another was sold, argued over, and locked away. Engineers who had built the most advanced spacecraft in Soviet history went unpaid for months. Some left to drive taxis, some sold off equipment, some simply walked away from the locked hangars. and the flown orbiter, the machine that had actually been to space, was rolled into a giant assembly hall at Baikonur, parked next to an Energia rocket, and left there. Not preserved, not displayed, just stored in a building nobody could afford to maintain. One man refused to surrender. Gleb Lozino-Lozinskiy, now in his 80s, kept pitching his life's idea. He called it Max, a small, sensible spaceplane launched from the back of the Energia, the giant aircraft built for Buran. No giant rocket, no army of factories, everything Buran should have been, scaled to a world that counted money. It was, in a way, his spiral again, the dream he'd started with in 1965, come full circle. He carried the blueprints to conferences, to ministries, to foreign investors, to anyone who would listen, into his 90s. The answer was always the same: brilliant. No money. He died in November 2001 at 91. A man who built flying machines for 70 years and chased one dream, the spaceplane, for his last 40, under a state that kept commissioning his dreams and kept dying underneath them. 6 months later, the story found its ending. Chapter 6, The Roof. May 12th, 2002. Baikonur, Building 112, the giant assembly hall where the flown Buran was stored. A hall built decades earlier for the N1 moon rocket. Everything in this story keeps landing on the bones of that program. The roof had been leaking for years. There was no money to maintain it. There had barely been money to guard it. That spring, 8 workers were finally sent up to repair it. The roof collapsed under them. All 8 men died. And underneath the falling concrete, the only Buran that ever flew, the machine that had landed itself through a storm meters from the center line, was crushed. Along with the Energia hardware beside it. No enemy touched it. No accident of flight destroyed it. The machine survived space, re-entry, and a storm. It did not survive maintenance. The system that built it could no longer keep a roof over its head. What remains today is scattered across the wreckage of the empire. The jet-powered test shuttle the Wolfpack flew wandered the world like a refugee. Sydney, then years stranded in Bahrain, until a German museum bought it and barged it up the Rhine. It is the closest most people will ever get to a Buran. A second orbiter, 95% complete, scheduled to fly in 1991, stands locked in a dusty hangar at Baikonur, covered in graffiti, owned, after years of court battles, by a private businessman. At one point, he offered to trade it to Russia for the repatriated skull of a Kazakh Khan. That is what became of the Soviet space shuttle, a bargaining chip in a story nobody planned. And the Energia, the greatest aircraft ever built, born to carry Buran on its back, was destroyed in February 2022 in the first days of the war in Ukraine, burned in its hangar by the army of the state that still dreams of the empire that built it. Energia means the dream, and the engines. If you saw our film about the N1, you know how this rhyme goes. Energia's booster engine, the most powerful liquid rocket engine ever flown, lived on. Its direct descendant was sold to the United States, and for 2 decades it lifted American Atlas rockets off American pads, military satellites, planetary probes, the backbone of American spaceflight, riding on the last masterpiece of Valentin Glushko. Twice now, the Soviet Union built engines that outlived it, and both times they ended up flying for the other side. So, was Buran better than the American shuttle? On paper, in several ways, yes. In reality, it proved exactly one of those advantages. It could fly without us. It was designed for 100 flights. It got one. One perfect flight, 51 weeks before the Berlin Wall fell. A machine that did everything right, built by a state that no longer could. In our last film, the system killed its moon rocket before it ever had the chance to work. This time, it built a machine that worked perfectly, the first time, with no one aboard. and it made no difference at all. The machine was never the problem. By the time it flew, everything around it already was. This has been Iron Curtain Industries. If you want the first half of this story, the moon rocket this program was built on top of, watch our film about the N1. Subscribe